Okay, recapping everything. If you see an A, what does it do physically? A description. It's a vertical stretch, or it could also compress depending on its value. It stretches if it's bigger than 1, and it compresses if it's like a decimal or a fraction, right? So in the coordinates, that's what it would do. Okay, so there's a visual. So something like this. This coordinate is now there. That's a way of vertically stretching something. Okay, if you have a B is a horizontal compression. But sometimes it could also stretch. You notice how I wrote those opposite? How does it compress? If that number is bigger than 1, it compresses. These are opposite, right? And it stretches if you have a smaller number. So those are opposite there. Make sure you kind of always remember X stuff is always opposite of your brain. So if you see a 5, your brain says bigger, but you need to think opposite of that. So the effect is X divided by B. Right? Because it's opposite. If you see a times by 5, you're actually dividing by 5. So this would be like a coordinate moving like this. That's how you're horizontally compression and stretching stuff. Okay, when you see a plus C, a C is descriptor, a horizontal shift. So in other words, you could be moving left or right on a graph. So the coordinate gets affected, X minus C. You notice how I wrote it? Another opposite. So if I see a plus, then it's actually going left. Okay, a D, so that's a vertical shift. And then up or down would be the way you could go there. So my coordinate would be y plus D. And that's the same, right? Whatever you see is what you write. If you see a plus 6, you write a plus 6. Okay, let's do the negatives. So this negative is which letter spot? It's an A. So you'd be changing the Y. Can you think about when you change a Y, then you're reflecting, and on your test, you can't just write me reflect. I'm not going to give you full points. It reflects how? Over the x-axis. there's your visual. So something there changed to there. Please don't reflect over like a shape. This would be a common mistake. So if I ever had a shape like that, it should look like this, right? That's a reflection over the axis. Here would be a common mistake. That's a common mistake. Don't do that, right? That's not what you want. You're reflecting it over the axis. Okay? Correct and wrong. Okay, what else we got? Another reflection, another negative. So this time we got a negative in the B position. So the B is on the X. So if you are changing your X values, think about your visual, if you change your X values, now you're reflecting over the Y-axis. So there's an example. Change the X values. Okay. Next, you need to remember the symbols. So what does this symbol mean? So you had your absolute, you had a reciprocal, and you had an inverse. Which one of those is this? Inverse, which means to do a switch. Okay? You also need to be aware that it's a reflection over y equals x, which is the name of the diagonal, right, with a slope of 1. That diagonal, it also visually does that. Okay, next. What's the name of those symbols? This is our absolute value. And it only affects the y, right? Because f of x is another way of saying y, so we're absoluting our y. Let's write some quick rules here. If we have a positive y, then we stay positive. If we have a 0, we stay 0. And if we have a negative, it changes. We don't want negatives. Okay, and then the last one, so that name is a reciprocal. So a reciprocal function is flip-flopping fractions kind of idea. Okay, I developed a process of step 1, step 2. So the first thing is I always started with heights of 0, because heights of 0 reciprocate to 1 over 0, which result in a asymptote. Then I did heights of 1 or negative 1, because those heights will stay, because 1 becomes 1 over 1. Same thing, doesn't do anything. And then we just kind of tried to fill in the patterns of things with, if I had a coordinate that was far away from 0, it would turn to close to 0. A close to 0 would go far away from 0. As in 100 became 1 over 100. So that's big, so that's really small. Does that kind of make sense?